I'm showing 244 volts from the top right-hand jaw of this open meter socket to the bottom left-hand jaw of this open meter socket, which is the same thing this creator showed in his video. In case you didn't know, that's not the meter reading you're supposed to be getting. Now, a couple other content creators have made their take on this, and I agree with their overall point that the original video does not have enough information to truly diagnose what is going on. Based on what he did say and did show, I've recreated what I think is the most plausible, likely explanation on what could cause that to happen. Side note, this might be the most expensive thing I've ever built for a single video, so hopefully I can reuse some of these parts in future videos, and hopefully you like the video. All right, let's get into it. So the other thing he did show is he had some lower voltage, I think it was 46 volts, with the main breaker off. And with the main breaker on, he went up to full voltage. So just to make the numbers a little bit less confusing and more clear, we're going to show my video in low Z mode, which allows that main breaker to being off to actually show the true zero that it is. I'm killing all power over there so I can explain to you what's happening. So now ignore the fact that this says 0 for this part. That just means I'm in a safe condition. It's not part of the explanation. What he said was the problem is the hot and neutral got reversed. As they went up the service mast, they're supposed to connect to hot, hot, neutral. And this got connected to a hot and that got connected to a neutral. And to make it easier to see, the wire connected to my neutral down here is copper and the one connected to my hot is aluminum. But if you look up here, I have indeed connected what should be to a hot to a neutral and what should be a neutral to a hot. While that is the major repair that could cause this problem that needs to be fixed, that alone would not give you the meter readings you were getting. He needed to have loads and branch circuits connected to his panel, as far as I can tell, and he didn't show that in the video. So if we are feeding 240 volts into these two conductors, how does that get the 240 volts to these two conductors also? Well, let me show you. So what has happened, because we have loads plugged in, we now have a conductive path from this wire to that wire, allowing our meter to read that 240. Let's follow the path. So this is now part of the energized path. It goes down on this white wire, which comes through and now has energized the neutral bus, which now has made this part of the conductive path and energized to this receptacle, which now has a conductive path through the hot plate, back on the hot, through here, gets to this black wire, which now this black wire, because this breaker's on, has energized this bus, which now has a conductive path with this breaker's on to here on this black wire, which comes back up and through to there. What he didn't show is this is energized, and not only does killing the main breaker make us lose our voltage, so would unplugging the hot plate. All right, thank you very much.